welcome to the channel. This is CCNA course, day 29. We are talking about advanced topics. Network address translation is going to be the one. But I'm just going to speak about the theory of that, the terminology, the different types of NAT, and then in the next video, I'm just going to show you the configuration and verification of NAT. But the most important part of NAT is understanding why do we have this at all? What is NAT at all? So you know that we have two different types of IP addresses, right? One of them is going to be IPv4, which is or has been around for a very, very long time, maybe something like more than 50 years right now. And then we have IPv6, which is a little bit newer, I guess, 1990 something, and this is going to, address all the shortcomings of IPv4. Now, what is the difference between these two? IPv4 is 32 bits, so we are going to have 2 to the power of 32 addresses, which is going to be something like 4 billion addresses. Now, IPv6 is 128, so that's going to be 128. So that's going to be something like, I don't know, infinite number of IPv6 addresses that we can have. But the problem with IPv6 is it is long, it is some kind of boring to work with, kind of confusing to work with. So a lot of people really do not want to go towards IPv6. And I remember that in 2003, the US government mandated using of IPv6 addresses in the state organizations or any government organization that there is in the US. But so far, it is 2026 right now, and we are still using IPv4 as the main IPv6 IP addressing scheme. Why? Because that's much easier to work with. But we have 4 billion addresses. This 4 billion addresses, of course, is not useful all at once. So you can see that we have different classes, class A, B, C. These are useful for unicast. Then we have class D, which is going to be used for multicast, and then class E, which we do not really use it at all. What we do is we just waste a lot of IPv6, IPv4 addresses, and there are just these 3 ranges of IPv addresses that we can use. And from these 3 IP addresses, we have some reservations as well. So we do not really use the whole 127 block. This is reserved. We don't use anything from 10 block because this is used for private. 127 is used for loopback, and then we don't use anything from 172.16.0.0. We don't use anything from 192.168.0.0, and also we don't use anything from 224, 169, something like this. I'm not so sure. Not 224. That is called API range. I do not really remember the range, but something like this. That this is the API range that we do not really use. So you can see that a bunch of IPv4 addresses are not useful for us. We cannot really use them. We can use them for different purposes, but not for global routing. So what we need to do is to make sure that IPv4 addresses are replaced with something better, a bigger range of IP addresses, and that is IPv6. But we still want to use IPv4 for some reason. Before IPv6 comes into picture, we figured out something. We said that, okay, we have these private IP addresses. We can use these private IP addresses in many different places. We didn't have this before, actually. We just allocated this, and this, for many years, a lot of organizations didn't really need to have public IP addresses inside their organization. So that was one of the first things that we did. We allocated some addresses like this one, and this one to private range, and this solved our problem for some time. But when we did this, there was some problem. If I wanted to, allocate this address to a PC inside my network, let's say for example 10.0.0.1, this was a private IP address, and this could not really get to any host over the internet. So on the internet, we had this problem of routing, and this is private IP address. Private IP address cannot be routed on the internet. So what can I do to solve this? the problem was solved with a technology which we call it a NAT, Network Address Translation. What we did was we had some kind of private address in here, then public address in here, and then when we wanted to send the packet from this side to the outside, we changed the IP address on the packet to a public address, and then we sent it towards the destination. And when we received the reply, we did the opposite, and we passed it inside, and then we could just receive it on the PC that sends the packet, right? So that is the overall picture in here. What we have here is we wanted to make sure that from inside to outside, there is kind of a change in the IP addresses because we didn't have so many global IP addresses or public IP addresses. So we just tried to use some of them and then translated the internal IP addresses into that. Now, I'm just going to speak about this a little bit more, but now you know why NAT exists. Because IPv4 has a limited number of addresses, private IP addresses are not routable on the internet, and NAT allows many private hosts to share a small number of public IP. Just one is going to be super important. I'm just going to explain this a little bit to you. Now, the key to this part is something that we call it a port number. So we have spoken about port numbers a little bit before. Do you remember that? So some of the port numbers were used as the well-known ports. For example, you know that port 80 is for HTTP, port 434 for HTTPS, 20 and 21 are for let's say FTP, 22 is for SSH, 23 is for let's say I don't know Telnet, and 50 something for DNS, and some of the port numbers have been assigned. So these are the well-known port numbers, but we do not really use these. What we use is a range of port addresses that is not used for let's say these well-known things. We allocate something, we have something like 65,535, I believe. Let's say 65,000 port numbers. And then some of them, something like 2,000 of them, 3,000 of them, let's say I said 10,000 of them, has been registered. So we have something like 50 something thousand port numbers that we can use. Now, when I have a computer inside my network with an IP address of 10.0.0.1, sending a packet to, let's say, 1, 2, 3, 4, this is a public address, right? This is a private address. This is not routable. I need to do something about this. What I do is I have a border in my network. There is a router in here, which is the NAT server. Okay, this is my internal network. This is my external network or public network. And then this has the private addresses inside and some public addresses outside. So the public address is routable. What I do is I change this private address to public address, and then because I have many devices here that all of them are going to use the same IP address, I use a random port number for each one of these hosts. So 10.0.0.1 is going to be translated to something like, I don't know, 8.1.252.120. And then in front of that, because I want to use this address for many different hosts inside my network, and I don't have so many public IP addresses, I just want to use this for, let's say, 10,000 computers inside my network, I'm just going to allocate a random port number. I'm just going to say port 22,101. That is going to be like this, and the destination is 1, 2, 3, 4. Now we should have a port number in here because I'm trying to reach to a specific let's say service. For example, this is going to be over 80, and that's going to be over 80, but I don't care about the destination. The destination is already a public address. My internal network is different. So you can see that I have a source of 10.0.0.1, and I am just changing this to 8.1.2.52.120. And then because I want to make sure that this is for 10.0.0.1, I just allocated a port number for that. I have this inside a table, and I call this a NAT table, a network address translation table inside my network. So I'm just going to use this and have this, and when I receive the response back from 1234 281.252.120 to the port 222.101, then I'm just going to understand that this is for 10.0.0.1. I change it and send it inside my network. So say there is another computer in my network which is trying to reach to some other address. Let's say for example that it is 10.0.1.21, and this is trying to reach to 8.1.8.8 over, let's say, port, I don't know, 443. So I'm just going to translate it to 81.252.120. You see that the same IP address is used, but I'm going to allocate it a random port number 22102, for example. And I'm going to send it to 8188 on port 443. So you see that this is how I make sure that internal addresses are able to reach to external addresses. Private addresses are able to reach to public addresses. So that is the overall usage of NAT that I just told you. So you just saw that with just one IP address, with so many ports that I have, I can service something like 50,000 or even more computers inside my network. So say I am an enterprise. My enterprise has something like 100,000 computers that all of them want to reach the internet. So what do I need? Two addresses tops with the range of, let's say, port numbers that I already have. So two is going to be enough. I can even have more than that. Let's say, for example, service providers do something that we call it carrier grade NAT, CCNAT, or NAT in NAT, something like that, right? So, or NAT 44. There are different names for that. So all of them mean that there is two levels of NAT. This means that I can have one address allocated to something like 3 billion, 4 billion different devices, because I am translating two times. Although there are so many limitations for them, but this is possible as well, okay? But right now, I'm just saying one level of NAT is enough, and with that, 50,000 at least computers can use only one public IP address just to reach the internet without any problem. So in this slide, you see why do we use NAT? First of all, to allow internet access for private networks. Like I said, when changing ISPs without remembering the internal network, you don't really care what is your private IP address. You're receiving this via DHCP or something. You don't even care about the public IP address. That is the responsibility of the NAT server or your service provider, in case you are just connecting using a service provider to the network. And also, the next thing which is important is when merging networks with overlapping IP address ranges. Okay, let's say that I have private IP address in my network, and I have just bought another network, another company. The internal network of that company has the same range that I have. This is very possible. So what can I do? I can just translate my private IP addresses into another private IP address, and vice versa. That is another use of NAT in your network. Where NAT is implemented, NAT is typically configured on the border router. You just saw this, right? I just draw this here. There was a border router even in here. That is the, let's say, boundary between my internal network and the external network. That is where we use NAT. There are other separate inside and outside network. Now, two great things that we have in here, two great terminology. You should know that your internal network is called inside. Your network which uses the private IP address is called inside. But the site that uses public IP addresses is outside. So you should know inside to and outside. And that configuration requires inside and outside interfaces. There are at least two interfaces, one of them connected to the inside network, one of them connected to the outside network. So you need to tell them which interface is inside, which interface is outside via the configuration. I'm just going to show you how you can do that. And finally, what advantages did we get from that? We conserved public IP addresses. Two IP addresses just for 100,000 computers. That's insane, right? Also, the outside network cannot really know what is the IP address allocated to the inside network. That is a level of security as well. And also allows flexibility during ISP changes and migration. You don't really care what ISP you're connected to. Your internal network is going to stay intact. Your external network, this is going to be the responsibility of the ISP to allocate some public IP addresses to your private IP addresses on its own NAT server. So there is no problem with that, but there are problems with the overall process. What are those problems? First of all, breaks end-to-end visibility. In some place, we have a change of IP addresses. This means that whatever I receive on the outside, I don't really know what it has been in the inside. So the visibility is going to break in here. Sometimes this is good most of the time, but sometimes we really want to have this kind of visibility. Specifically for some of the applications that do not really work with NAT, this is going to be important. It can cause application compatibility issues. Some of the applications, like I said, do not understand NAT. So you cannot really go with that kind of an application. Most of the applications, of course, that we use these days are NAT compatible. Some of them do not understand NAT in NAT. So if you want to do NAT twice, and most likely your service provider does that, some applications, I remember Skype was one of them, for example, does not understand that. So you cannot really do this on your internal network, or you cannot really allow your service provider to do that. And also add processing overhead on network devices. There is a translation, there is a change in the header of the packet, there is part of memory that we need to keep for the state of the NAT translations that we did, right? So that's going to require some amount of memory, specifically if this is a heavy traffic network. So like I said, NAT has different types, but let's just see what we had in here. I have three different types of that. One of them is static NAT. Static NAT provides one-to-one address mapping, so port number is not going to be used in that case. This is useful, but not always. Also, I can just make sure that port number is going to be assigned, but specifically I am telling the NAT translation table what to translate to be translated to what. In that case, for example, again, a static NAT is done, but I would call it a static path actually. We have dynamic NAT, which is going to be automatically done by the router, which is on the border of my network. And also we have port address translation. This is something that we generally call it NAT, right? Most of the time we are just referring to this one, port address translation. So again, we are going to be going to translate the IP addresses, but this time port numbers are going to be very important for us. So in here, static NAT and dynamic NAT, we are translating one to one, but in path we are translating one to many, which is going to be super useful for our case actually. So if I just go through each one of them a little bit more detail, for static NAT, each inside local address is permanently mapped to one inside global address. Later we are going to talk about this terminology a little bit more, but you should know that I am just changing this to a bigger picture, let's say a specific type of terminology that we have. We require one public IP per internal device and commonly used for servers that must always be reachable. What it means is I have my internal network in here. I have a server inside, and this is my web server, which is going to be available from the internet, right? So this is a private IP address range, and that is not routable. What I need to do is to translate it right in here, and then send the packets inside, and then get the response and take it back in here. In this case, I really need to do something which is called static net, and that is going to be important for my case in here. So the other thing is called dynamic NAT. Inside the addresses are translated dynamically using a pool of public IPs. No port numbers are used, like I said, and number of simultaneous users is limited by pool size. Pool means the number of the range of IP addresses that we have available for translation in here. But paths, like I said, is the one that we use a lot in our network. And when you configure that, this is not called path when configuration, when doing the configuration, it's called NAT overload. So we use port numbers in here, and that means that we have many internal IP addresses translated to one public IP address, as many as something like 50,000 something, right? And this is the most common NAT type that is used in here. But like I said, this one is very important. So let's say that, for example, my NAT server is here. This is my boundary. Inside local IP address is the one that is allocated to the device itself. So my IP address, my private IP address is inside local. So I just call it my private IP address, right? Now, inside global is the one which you are translated to, right? And most likely this is the same as, the IP which is inserted on the packet itself when it is going to be sent to the internet. So inside global is going to be my public IP, right? Now, what is the outside local and outside, global IP address? Outside local is again very similar to my IP address. This is the IP address from me that my NAT server sees that. So most likely that's going to be the same thing, and most of the time you do not really care about outside local IP address. Outside global is your destination. So that is going to be your destination IP address. So these three are important. Outside local, maybe you're not going to, care about that a lot. So you don't really care about this one, but these three are going to be the most important and useful things that you need to know. So what you are going to add is your inside local IP address is going to be translated into inside global. Your outside global is your destination, actually. So how NAT works step by step, this one is going to again be important to understand. Inside host sends traffic towards the internet. Like I said, NAT router translates source address. Destination address is not going to be changed. Translation is stored in a NAT table as I showed you. And return traffic is translated back. That is the simple thing. And about the path, the same process of course, but this time we have a port number allocated for each one of the sessions that we have, which means that each one of the devices that are internal are going to receive a port number just to differentiate from the others when using the same public IP address in here. So NAT allows private networks to access public networks. PAT is the most widely used form of NAT. In configuration, we call it NAT overload. And NAT terminology is critical for CCNA exam that you need to know about that. I hope this has been informative for you, and thank you for watching. We are going to have configuration in the next video. Please like and subscribe to the channel, and also drop your questions in the comments. I make sure that I will answer that as soon as possible. See you in the later videos.